So it says in 2015, the federal debt was about $18 trillion. In 2015, the U.S. population was about 320 million. Assuming that the federal debt is increasing at about 4.5% per year, and the U.S. population is increasing at about 0.7% per year, determine the per capita debt, which is the total debt divided by the population in the year 2030. Right? So this is the rate of our debt's been growing, 4.5%. This is the rate that our population is growing, which obviously is not good, that the debt is growing at a much higher rate than the population. So we're going to try to predict what this is going to be. To do that, we're going to use the formulas we used yesterday. The main one that we use looks like this. A, which would represent like the future value, equals P times 1 plus R over N to the NT. So we used yesterday. And we're going to try to find the future value. So what's the debt going to be in 2030, and then what's the population going to be in 2030? Right? 2030. I'll write it over here. So the first thing is $18 trillion. What does that even look like as a number? Let's write that out here. So we're going to have A equals, and then obviously it's going to be 18. And let's think about how many zeros we need. Let's keep adding zeros, and let's write a bunch and see if we need to add more. All right, so here I've got 9 zeros. Let's count what this would be. So we've got our hundreds, our thousands. This is our millions. This is our billions. So we need 3 more zeros. So that's what $18 trillion looks like. An 18 with 12 zeros on it. Right, and then we need the 1 plus R over N to the NT. So we're going to multiply this times 1 plus our rate. Our rate here, the federal debt increase is 4.5%. So what is that as a decimal? Yeah, 0.045. So plus 0.045. Our number of compounds, the N, this says per year. So it increases per year. That just means our number of compounds is just going to be 1. So we don't even actually have to write it. You could put over 1, or you could just not even write that over 1. It's a little easier to type in. And then to the NT, well, the N is 1. So 1 times our time. What is our time?
8 years.
Yeah. Huh? Yeah, 15 years, because we're looking at 2015 and then predicting 2030. So we got 15. It'd be 1 times 15. That's 15. All right, so take a second and see if you can type that in. And again, this will be what the projected national debt is in the year 2030. And the way that it's written, it will look kind of weird, probably. If you did it, it probably looks like this. A bunch of other numbers, e to the 13, right? That just means you have to move the decimal 13 places. So I'm going to write out all these numbers. 3, 4, 8, 3, 5, 0, 8, 3, 9, 8. All right, but that isn't all of 13. That's if I counted them, that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So we actually have to add 4 more zeros. 1, 2, 3, 4. And then let's put in some commas so we can figure out what this is. Put a comma after 3, another comma, another comma, another comma. So this would be 34 trillion. 34 trillion, 835 billion dollars would be our projected debt in the year 2030. So increase from 18 trillion to 34 trillion. Now we're going to do the same process with our population. So our population, we in 2015 had 320 million right here. So that's going to be our starting amount, 320, and then million. Let's add the right number of zeros here. It's going to be adding 6 zeros. 320 million, and then it will be 1 plus. Our rate is going to be here. It's 0.7%. Now, when you write that as a decimal, you still have to move it over 2 places. So it's actually going to be 0.007 is our rate. And I'm not going to put it over 1 again because it's yearly, so we don't need to do it over 1. Just make harder to type it in. And then it'll still be 1 times 15. Let's try that one. 320 million. All right, and you can round this up. Should get 355,297,406 people. So our population should be about 355 million. And now the question is to find the per capita debt. So that means how much debt would each person have to pay? Like, let's say we're going to pay this off. All of the countries our country owes money to, everything. We have to pay it off. So how much would each individual citizen in our country have to pay towards this debt? So to get that, it says we're going to do the total debt divided by the population. Let's try that. We got about 98,000, so we guys getting 98,000. So per capita, that means per person. Each person would have to pay $98,044.86 in order to pay off the debt. And that's even including like infants and 3-year-olds or whatever. Every single person in the country would have to pay that. If we were to be debt free, if we want. And there's actually a website that keeps track of this. It's kind of neat. It has a lot of different statistics I'm going to pull up. It shows our current national debt, and we can compare it to this. So our current U.S. national debt is 30 trillion right now, and we projected it would be in 2030. We said it would be at 34 trillion. So it seems like we're probably a little bit ahead of pace. We had like a bunch of stimulus and all that stuff, so probably put us a little ahead of that pace. We probably surpass that by the year 2030 if we continue this rate. But we are at least on that page. And then we said the per capita debt will be 98,000. Currently, right now, it is 91,000 per citizen. It's kind of neat. Obviously, this isn't exact numbers, but this is what their estimate is. And you can see all kinds of different stuff. Like throughout the years, how this has changed. Our debt to our GDP. So it used to be less than only about half. Now it's more than double what our GDP is. That means we have more debt than we make in money each year. So that's not good. Not a good place to be. Here's our largest budget items: Medicare, Social Security, and defense. But yeah, these programs didn't used to exist, 100 years ago. Medicare and Social Security. So that's part of the reason we're in a lot of debt. Some other things that are kind of interesting. Debt held by foreign countries. You can see a lot there. It's 7 trillion. Our trade deficit's really big, especially with China. How much our government brings in tax revenue. What that breaks down per citizen. And some other things there. All right, so currently our population is 332 million. This is how many people are working. The official unemployment numbers are like about, it's like 6 million, but actual unemployed is 12 million. That's because a lot of people have stopped looking for jobs. These things are interesting over here. In 1913, so about 100 years ago, oil was $2 a barrel, and right now it says 64, but I think it's actually closer to $100 a barrel right now. So the last 100 years changed a lot. Another interesting one was the crypto one. So just less than 10 years ago, crypto to dollar was about $9,000 to one, and now it's like 10 to 1. So crypto used to be really cheap, now it's not. So other interesting things here. If you look at the home sales, how the prices of homes have gone up. We looked at this the other day, but this is like the new home median price. To build a new home, the median price right now is $404,000. So it's pretty crazy. That's the middle number. And then versus an existing price, the median cost is $354,000 right now. Yeah, that's kind of crazy. And they used to be, even before COVID, you look like pre-COVID in 2019, it was 284, and now it's gone up to 354 to buy just an existing home. Yeah. Right. So prices have definitely gone up a ton. If you look back though, you'll see here they actually went down briefly. Right here, 2009, 2010 home values, and the prices actually went down. And that's when there was I think they call it the Great Recession. There was it's called the subprime mortgage crisis, where people borrowed more money than they had, and banks were handing out so much money. How old was I? In what year?
You said you seemed like you weren't a part of it.
No, I was. Yeah.
Oh, okay.
I graduated 2007 from high school.
Oh, okay.
Yeah, I didn't have a home back then, so. But yeah, it's not that long ago. 10 years ago, and houses were half the cost back then. Right? 10 years ago, they were in the 170,000. Well, yeah, that's definitely the cause of it. Yeah, and so it's crazy though, just how much it's changed in 10 years. So at some point we'll have to level off, but one of the big things, as I said, was Social Security and Medicare, Medicaid, all of those. We're obviously are going to make it in Social Security and Medicare by the time we're old. I don't know if those will still exist or not, but don't count on those. Probably not going to be around. That's something changes. Pretty neat stuff. All right. Today, we're going to continue talking about this financial stuff. And there's one formula we didn't quite get to yesterday that was called continuously compounded interest. It's really easy. I'm going to show you that one first. And then we're going to talk about what's called present value. So let's say we want a certain amount in the future. How much do we need to save now in order to make sure we have that amount in the future? So that's going to be our main topic for today. Still doing the same section and everything, just kind of in reverse. But the one we didn't get to yesterday was called continuously compounded interest. So just constantly, the interest is compounding on itself. And it turns out E shows up in this formula. So back before break, we talked about E's and natural logs. And E shows up in this formula here. So it's the future value. So the balance is equal to the present value or the principal times E to the RT. And this E, if you just remember, it's just the constant. You're just going to be plugging that in your calculator. Constant. So you're not going to replace E. You're going to replace all these other variables which we had. This we call the future value. This is the present value. This obviously is our rate. And then we got our time. All of these things, and the E is just E on the calculator. Right. So this is very easy to use. It's just if it says your rate is compounded continuously, this is the formula you're going to use. A equals P E to the RT. So just do one quick example of this. If you invest $1,000 at 11% interest compounded continuously, after 3 years, like how much you can have. So everything just plugs in our future value in that 3 years. A is going to equal our present value of 1,000 times e to the r, our rate, which is 11%, so that's 0.11, times our time, which is 3 years. So we're just going to set it up like that. You just need to write that out and then plug it into the calculator. And you should do this. If you don't have a calculator, you can get up and grab one, but just make sure you know how to type this in, practice it, so you can find E. Can't ask someone next to you or ask them. Make sure you can type that in. And then always make sure your answers seem reasonable too. If you get like $20,000, that's probably not going to be reasonable. And it should be more, so it should be more than 1,000, but not unreasonable. You got 1,391 because it does round up. $191. Anybody struggling to get that typed in? Make sure you ask it. Yeah. You do seconds, and then you hit the element. That's right. Hit your elements. And you want to do 1,000. Yeah. To find the E, you hit seconds, and then the ln button, and that gives you E to the power. If you're struggling to find it, second ln, you want to do 1,000, second ln, and then 0.11 times 3, close your parentheses. Oh. Okay. So again, that's pretty easy. You're just typing it in there. The main thing we're going to do today is answer a question like this here. So yesterday we figured out how much a home was going to be worth. Today we're going to figure out how much money we need to save for a car. So we got 6-year-old Billy. He really likes red race cars. So he decides he's going to save up. He wants to invest some money to make sure he can buy a car like this when he turns 16. So age 6, Billy wants to invest all the money that he has into what's called a CD. It's called just means a certificate of deposit. What that means is you put your money in this account, and you can't touch it until it expires. Most of them are 5 or 10, or you could do 50 years. So you put your money in there, you're guaranteed a return, and then you can get it out in 10 years. You can't get it before then. So he's going to get a certificate of deposit or a CD for 10 years, and he wants to have $6,000 saved. He thinks he's going to be able to get a good enough car for $6,000. So he wants to have that saved, and he's going to figure out what he needs to invest now to have $6,000 when he's 16 years old. All right? So what we're actually trying to figure out is not what we've been doing is this A equals P times 1 plus R over N T. What we've been trying to do is figure out this future value, right? But we already know the future value. We know he wants $6,000 in the future, right? So now it looks like this. We got $6,000 in the future, and we want to figure out what this present value is. We want to figure out P, because we know all the rest of the stuff. One way to do it would be to just take this equation and divide it. So if we just plug everything in, well, the rate is 5%, so 0.05. It's monthly, so N is 12, and then 12 times 10 years later. So one way would just be to plug it into this formula and then just like divide it over, right, to solve for P. And you can definitely do that. And then so P would just be this divided by this. Your textbook, and generally if you see this formula written out though, when you actually solve for P, it's really just A divided by all this stuff, right? You would just use algebra to divide. You can write it like this, it's fine. But since there's a fraction inside of a fraction, typically how this equation is written looks like this. if we rearranged it like I just did there, typically the equation, we write it like this. With a negative exponent, it makes it a little bit easier. Come back to that problem in just a sec. But these are our present value formulas. So it's the same formula we've been doing. It's just we solved for the A. Before it was A equals, and now we're switched around, and then we got P equals. And so the only thing that's different is there's a negative symbol up here, and we switch the A and the P. Because a negative in an exponent means it goes to the bottom of the fraction. So it's just rearranging it. It'd be the same thing as writing P equals A over this 1 plus R over N to the NT. Right? We just use algebra. Just instead of writing it as a fraction, it's just always written with a negative exponent. Because that's the same thing. Okay, that's how exponents work. Negative exponent means the bottom of the fraction. So we can take it out of the bottom and just throw a negative up there. So we switch the P and the A, and then we have a negative in the exponent. So that's called the present value, if we want to solve for the present value. And then the same, this is continuous here. Continuous. And it's exactly the same, we just switch the P and the A, and then you throw a negative in the exponent. Same thing as before. So that's what we're going to be working with today. It's not really any harder. Again, all you're doing is switching two numbers and putting a negative in the exponent. So let's figure out how much Billy needs to put into the CD now. Figure out how much he'll need to get that $6,000. Maybe his parents can help him out or something. And so this idea can also be used if you want to like save a certain amount for college. Maybe like as a parent you want to save some money for your kid for college. You could put it away and then just watch it grow. All right, so he wants to have $6,000. So now we're going to be solving for our present value. Our present value is going to equal our 6,000 future value times 1 plus our rate, which is 0.05, 5% compounded monthly, 12. And the 12 times 10, but we need to put a negative symbol up there. We switch the A and the P and we throw a negative up there. And you can also just multiply this in your head and just write negative 120 if you want to really type it in. But take a second to try to type that in. You can always double check to make sure your answer makes sense as well. Should be a number less than 6,000. Also make sure you're closing your parentheses. And I got $3,642.97. So that's how much you would need to put into a savings account, save up enough allowance money or something like that, birthday money. Put $3,643 in there and got $6,000. Sometimes like older people do these certificates of deposit. I remember my grandpa buying these because they're really secure. You don't get a ton of interest, but they're really secure investments. All right, let's look at just a couple more real quick, and then I'm going to give you a lot of time to work on the problems for today. Just a couple more using that formula. If we want to get $500, we want that $500 in 2 years, and we're going to get 7% compounded monthly in this. We want to find the present value, because this is our future value. We want how much we want in 2 years, $500. So our present then is going to be 500 and 1 plus 7% is 0.07. Our number of compounds is monthly, it's going to be 12. And the easiest thing to forget is the negative up there. We forget sometimes too. Because we're solving for the present, we need a negative up there. And then it's going to be 12 times 2 years. Or you can just write negative 24, that's fine. Do that in your head. And type it all in. As long as you figure out the right formula you're using for these, it's really not bad. But hopefully find it just somewhat practical, figure out how all those things work. And we're getting $434 and 86 cents. We'll get about $65 after 2 years. Doesn't seem like a lot. All right, now last one of this type. Say you want $10,000 in 6 years. Maybe when you go to college, when you graduate from college or something, you want to have $10,000 saved. Let's see how much you need. Go ahead and try that one on your own. Should be 10,000 times 1 plus 0.08 divided by daily. That's 365. And negative 365 times 6. I got 6,188. That seems reasonable, right? Put in 6,000 now, and then in 6 years you'll have 10,000. So that's pretty good. See, it definitely pays off to invest. Okay. All right, and then I just want to show you one with that continuously compounded one, and then we'll be it. Whenever you see continuously compounded, I think it's got to have an E in it. Okay. Those are the only E formulas that it's continuously compounded. And then you can see we'd also come up with a possibility of getting a natural log if we ever need to undo that. We go with natural logs. So that's why this is shoved into the natural log chapter. But let's see if we can solve this. We're going to use this formula here, the AE to the negative RT. We want $80 in 3 1/4 years. Doesn't seem like a lot, but you know, present value is 80 in the future. E to the negative R is 0.09. And then the T is 3 1/4. So let's put in 3.25. And then all of that goes in your calculator the same way we did before. 80, and then you get the second natural log to get your E. And we gotta put in $59. So I'm going to give you the rest of the time to work on the problems, and I think you should be able to get them all done. We'll pull them up here. You're going to do 2 word problems at the end. The other ones, just make sure you're using the right formula. Your first 2, your first 2 are at the end of the last section we did yesterday. So this is when you're looking for the future value. So you're solving for A. And then the next section here, you're going to be solving for P in all of these, present value. And then you got a couple word problems where you got to figure out which one to use. Right? the first two are kind of what we did yesterday. We're gonna how much is going to be in the future, and then the next section is all present value. So you're going to be using the P formulas, and remember if it's continuous, then you're going to use the E, and then you got 2 word problems on the next page to do. If you're going to work with someone, definitely do that. And goal is you can get them all done. So ask for help. Make sure you work on them so that hopefully you don't have any homework.